Through a quick example here of doing a manual S speed sheet. And so currently the project that I'm doing, I wanted to show you the CoolCalc online, but then apparently it's off for scheduled maintenance. So and unfortunately I don't have time to record this video after 3 o'clock today, so I have a different load pulled up, and I just circled the areas that we need for the inputs on the manual S speed sheet. Some differences in this load. I'm on the verge of different winter design temperatures. So the one we are doing has a little bit lower outdoor design of 5 degrees. And then obviously we'll have different BTU values. Because like I said, this is for an old project that I just pulled up the Manual J report for, but I wanted to show you guys where you get these, and they're right at the top of the first page if you're using CoolCalc. So next we are on to the Manual S, and so your first page gives you instructions on which sheet to use based off how your manufacturer has their data laid out. So these are kind of confusing. I find it best to read this little example underneath them. Tends to work out a little easier to understand. But for me and my manufacturers, I almost exclusively end up having to use this Form C. So, first off, obviously, we'll just put you want to fill out your client name and address, and all that identifying information. And then for me, on my template, I already have default values over here, so I don't have to fill them out every time. But those would come from here, your summer and winter design, and then your set points. So then I like to put the model number of the unit that I'm going to use. So for this one, we're going to try a 3-ton. I wait on the air handler and coil, which I'll show you in a minute, but you will want to come back and fill that out. So in the Manual S, all the yellow fields are fields that you want to fill out based on your application. Some of the lower ones are only if applicable, but so we'll start filling out our heat loss and cooling losses, gains. So this, I actually had recorded my values from Manual J. I just hadn't printed a report yet, so we're going to be using this column to fill out our Manual S example. So our heating BTUs 61,554. Our total cooling is 34,876. And then our sensible is 29,000 645. Okay. And so next, the other piece of information you need is your manufacturer's specifications. And each manufacturer is different in this regards, but let me get to the 3-ton model that we're going to start out with. Sorry, I should have had this prepared, but alright, so we are on this 3-ton TH16. We have our high performance data out. And so now we are going to start filling out the Manual S speed sheet with the manufacturer's data. So let's get back to our speed sheet here. We're going to start out with 1200 CFMs, and then this manufacturer, which is Champion, has these green columns are your standard cooling values at a 75 degree indoor and a 62 degree wet bulb. And also just something to show you, these are the values that we're looking for on the chart. So I'm looking for the column at 95 degrees and that 75 degree indoor. So here they use decimals instead of the totals, but that's 32,600 BTU total. And then our sensible is 26,300. And then next we are looking for the 105 degree column. We're doing this because S1C will calculate, since my outdoor summer design is 90 and I don't have that option in my manufacturer data, we input the values from the manufacturer above and below it, and then it will calculate whether it's a good fit or not for us. So we are going to go back here and look at the 105 column, which is over here. So that's 26,700 for our total, and 22,500 for our sensible. So at this point, we will get red or green flags down here, and this example just works out with the normal 3-ton. So we're all within our limits. The part I forgot, I apologize. This is a drop-down menu, the system type. It's important you get this correct based off the piece of equipment. So for me, this is actually wrong. The equipment type is an air-to-air heat pump, variable speed compressor, and I am a mild winter or latent load climate, which is where most of us would be. The cold winter or no latent is either, in the desert somewhere or really far north where you don't have much of a cooling load. But in most green grass climates, we're going to choose one of these values from mild winter or latent load. So you have single speed compressors in cooling or heat pump, multi-speed and cooling or heat pump, and variable speed and cooling or heat pump. So we are an air-to-air heat pump variable speed compressor, mild winter or latent load. So what that does is change your oversizing limits down here. And just to show you, we'll get to it in a minute. I'll do a different one. But on this one, our next step is the heating performance. So that is another section of the manufacturer's literature, and the thing I want to make you aware, at least for this manufacturer before scrolling down, is, you want to make sure you're reading all the fine print, any notes that there are. So for example, this one, if I choose a different air handler, I actually have to adjust my total and sensible BTUs, and we'll also get to that in just a minute. But for now, we are scrolling down to our heating performance data. Here we go. And so at 1200 CFM at 47 outdoor temperature, we have a total of 35,200 BTUs. And then we also need our 17 degree data, and we are 23,700. And what this does is just helps you determine your kilowatt usage and your balance point. Oh, sorry about that. So you'll see here our balance point is 35.1 with an outdoor design of 5. I'm not real happy with that. So here my manufacturer has a choice of 12.5 kW heat strips, so that seems like a good fit. I could also use 15 kW and I'll be within my limits. So that's the completed Manual S. If you get red flags here, then there's a problem and you need to select a different piece of equipment or a different matchup, which we'll actually go through now. As I said, this one, you'll see my total heat loss of 61,554, and so that means that our balance point, which is essentially the point that our heat pump is going to stop winning the race, and we're going to need to go into resistance heat, which we want to try to minimize. And so to me, 35.1 seems like a temperature that we're probably going to be at quite a bit in my climate. And so what we are going to do next is see what a 4-ton heat pump is going to look like. So I'm just going to make a copy of this so I don't have to refill everything out. We are going to change this to a 4-ton heat pump. Our heat losses are going to stay the same. And then we will go back to our manufacturer's data and scroll on down to the 4-ton version. Alright, so here you'll see we have the 4-ton version, and it looks like their standard or the middle performance data is 1400 CFM, so we need to update our speed sheet for that. And then in our 95 degree output, we have 42,700 for total, and a 31,800 sensible. Now our 105 degree column is 36,800. And our sensible is 29,100. Alright, so now you can see what one looks like if you are not meeting the requirements of Manual S. And so it does give us a little bit of information here. And so you'll see that we have gone over on our latent capacity. Sensible is good. Total capacity, we're kind of borderline. We're just over, but that's kind of close. So next we can deduce from this that latent is our problem. So what I would do from there, the way to reduce your latent capacity would be to increase your airflow. So let's look at the 1600 CFM columns and see if that is a fit. So we have 43,600 total. Our sensible is 33,900. And then at 105, we are 37,500. And our sensible is 30,900. So you can see this didn't do what we wanted. And it makes sense that with more airflow, we're going to increase our total. So you'll see we're further apart from our oversizing limit on total. It did drop our latent some, but we're still not within the guidelines. So a 4-ton currently isn't working out. But so what I do at this stage is I look at the fine print and the different matchups available. And so you can see we have these multipliers here. It makes sense that I want to look for a matchup that lowers my total capacity and raises my sensible capacity, since I have a little bit of room on my sensible limit. So I am, and I guess, so what I want to do now is I'm probably going to take a shot at this unit that has so I'm a little bit less on total capacity and a little bit higher on sensible. So we're going to switch this back to the 1400 column. And then since I switched it back, we are going to go with our total capacity of 42,700 times 0.99, our multiplier. And then our sensible is 31,800. Oops. 31,800 times 1.05. Then we do the same for the 105 column. So we're 36,000 times 0.99. And 29,100 times 1.05. So that actually gets us within our limits. The thing I don't like about this is because for this project, which are details that you don't quite know, is it's primarily an existing system. We are adding a little bit of ductwork, but I'm not trying to reinvent the wheel. So since my manufacturer also provides data at 1200 CFM for this, I want to see what that looks like. And so what I'm going to do is come over here and use the 41,800. Oh, first off, let's change our CFM value. We're going to change our total to 41,800 times 0.99 using the same air handler matchup. And then our sensible is 29,700 times 1.05. You'll see since lowering the design CFM actually gives us more latent capacity. Now we're over. Of course, I have to fill out my 105 data first. So that's 36,100 times 0.99 and 27,200. Okay, so yeah, we're still over. And so next, so just to quickly look at this, you can see we have room on our total and sensible capacities since they're green, and we're over on latent. So next, what I looked for is one that is close on my or gives me a more of a multiplier. So I want to stay close on my total capacity but have a higher sensible multiplier. So for me, one of these with a 1.0 and the 1.12 multipliers look pretty good. So I'm going to try this one here. So let's keep our, so all of our total and sensible will remain the same. Our multiplier here just changes. So this is just 1, And this goes up to 1.12 for our sensible capacity. So change this one to 1 and this one to 1.12 for our multiplier, and you'll see this brought us within our limitations. Just kind of squeaking by. So I'm happy with this. At this point, I would fill out my air handler information, which was an AE 48DX21. Okay, and we also have to remember to complete our heating. So let's go on down here to our heating performance data. And we also have to remember to pick the correct column. So we are designing at 1200 CFM at 47 outdoor temperature. We are 52,700. And at 17, I did that wrong. At 47 at 70 degrees, we are 51,700. And then at 17 degrees, at a 70 degree design indoor temperature, we are 33,400. And so you'll see our balance point is a lot lower. Our kilowatt required has lowered some. So either the 12.5 or 15 kW options are still good. And so this is likely the system I would choose for this application. If you'll notice, we're designing around the same CFM as this version, but we get a lot closer to our heat loss. And so so you'll notice a big difference in heating capacities, and we're getting a lot closer to our heat loss. And so our balance point is 26.7 with the 4-ton versus 35.1. So it seems reasonable that even though that doesn't seem like a big difference, but in reality, we probably spend a whole lot more time above 27 degrees than we do at 35. So this is going to give us a lot better of a scenario long term. And so anyways, that is me going through and trying to show you some different things as far as red flags. I hope that you guys were able to learn something. My next step at this point, now that I know which equipment I'm using, I would then go to the AHRI website and fill in my SEER and HSPF. I'm not going to do that here, but just wanted to show you how quick and easy it is to do. You don't need a lot of information, and the main points or takeaways would be to read your manufacturer's data, get used to it, get comfortable with it, and then just try different options, try different matchups, and hopefully some of the tips that I gave you will be helpful. Anyways, let me know down in the comments if it was helpful or anything else you'd like to see. Thanks and have a great day.